Hello everyone and welcome to this Bob's Guide webinar. I am Neil Ainger, your Bob's Guide moderator today. The subject for today's webinar is the role of NoSQL in the next generation of financial informatics. We'll be discussing NoSQL or non-relational databases as they used to be known and what this database model offers financial institutions in terms of better speed, flexibility and other data benefits versus traditional tabular relations and relational databases. As the FS sector incorporates more big data, NoSQL usage is rising. Regulatory reporting, conduct, surveillance and monitoring duties have all risen since the 2008 crash, and this has led to rising data loads at FIs. You need to process more data in order to compute risk quicker. This allows FIs to run stress tests and spot opportunities before rivals. Firms need to spot fraud, tax or sanctions problems too in today's fast-moving FS sector, not to mention rogue trading. This data deluge is occurring at the same time as a restriction in budget, so FIs have to adjust to lower returns on equity post-crash and increased compliance costs. These are essentially the drivers for FIs rethinking their operational and database systems. The older relational database style of IT architecture is unable to consistently deliver the operational performance, scalability, cost, and flexibility that firms now need, hence the rise of NoSQL architectures, which nonetheless must still accommodate linkages to traditional structured databases, which are very prevalent at FIs. So with over 250 databases in the market today, developers have to be smarter than ever at matching the right database to the right problem in order to ensure the success of their applications. NoSQL can help in this regard. It can potentially help FIs to handle latency-sensitive real-time analytics, manage intraday trading with predictable data, deliver multi-asset class trading and compliance, and also analyze fraud patterns and reduce risk. Bob's Guide is very happy to be running this webinar today with our sponsors, Aerospike. And we'll be hearing shortly from our speakers. We've got Brian Bulkowski, CTO and co-founder of Aerospike, and Steve Yatko, who's the CEO of Oktay Technology. The wide-ranging discussion today will touch on database technologies, FIs' changing needs, and the causes of this rising data loads that FIs are suffering. It will offer practical solutions and advice to help FIs cope with this data deluge. Before we go any further, however, there are a few housekeeping points that I would like to make. If you have a question to ask our speakers, please go to the box on your screen and simply type it in readiness for the Q&A session at the end. I'll use it after the hour-long webinar, time permitting. The entire webinar will also be recorded, so if you miss anything or think a colleague would be interested later on, you will be sent a link to the recording. Without further ado, I'll hand over to our first speaker today. Steve, over to you.
Okay, thank you very much. I thought perhaps it might be helpful to give a little bit of background as to who I am and kind of why I'm here talking about, operational data stores, NoSQL databases, and big data in general. My history is I've spent over 20 years on Wall Street. 15 of that have been spent at Credit Suisse, where I served two primary roles. The first role, I came in to be the CTO of the investment bank, where I had the responsibility of essentially developing, designing, and implementing the mission-critical trading systems and analytic systems for the firm. In that capacity, it ranged from building the higher latency equity systems all the way down into the more efficient and programmatic electronic trading systems, going down into even HFT. So everything from the nanosecond end-to-end latencies to the micros to the millis, combined with the analytic systems that would go along with that. My second half of my career there, I was the global head and managing director of research and development IT, where I had the responsibility to move from my line job into being in charge of driving the entire next generation application and computing infrastructure. And in that role, I had a lot of responsibility in terms of incubating emerging technology companies, both infrastructure as well as infrastructure software and application tool sets and designs. As a result of that, we would incubate a lot of emerging products as solutions that we felt would differentiate the firm. And it's important, I think, to note, in that 15 years spent there was a really important time in the mid-'90s that I'm going to make reference to as it relates to the transformation I think we're going through today. It was a time where application development and infrastructure and IT in general were seen truly as a differentiator for the business. Firms were talking about competing with one another, starting to go after the number one spot on volumes and best, trading, best execution. And technology was a key differentiator on building trading systems. And it was very close partnership between the business and the application teams, together with infrastructure and designing them to be as fast and as state-of-the-art as possible. And then globalizing them, of course. But today, I think, as we've seen IT evolve from really evolutionary types of technology adoption, we're seeing now the big data ecosystem as almost as not as large as the transformation we saw in the 90s, where we went from mainframes to distributed computing, and we had that differentiation in partnership with the business. Today, the informatics space is transforming at a tremendous rate. It's perhaps the fastest rate I've ever seen in my career, and I've been doing, as I said, for 15 years solid at Credit Suisse. This transformation, though, comes with a few more challenges. Obviously, back then we were smaller IT shops. Today we're much larger with much tighter budgets. There's not a lot of money to go just invent a front office technology organization and go build trading systems. So it does come, the new informatics transformation that we're talking about today, definitely comes with a lot of organizational and process challenge. But at the same time, the need to innovate here is creating an entire renaissance in the IT stack. And we'll take you through that. But we're really seeing for the first time since the mainframe to distributed computing, a real transformation in all the technologies. We're seeing it, from the ground up, from storage and the transformation that's going there, up into the file systems, to the servers, even processor designs. In DIM, we're seeing advances there in Flash to complement, RAM. We're seeing new, as you see from, the entire focus of this presentation on the informatics and the databases and NoSQL. And then obviously even the tool sets around that. We're seeing the need for new types of monitoring systems as well as, application tools. How are they interacting with this new age infrastructure and application design? And the skill sets are transforming as well. And so it truly is a renaissance that we saw in the 90s, and for the first time since then, an enormous focus on business, app dev, and infrastructure, redefining this entire technology stack as true solutions, for the business. So as we go over to my slide, we talk about this new world-class big data ecosystem. It really, if we look at, the prior databases, they were more or less just applications. Whether you had Oracle or Sybase or Microsoft, it was an application. You had a very simple database, you had a server, maybe it scaled a little bit horizontally, but it was fairly simplistic in nature. These new designs are very much an entire system today. So very complex end to end. And we're seeing the transformation going from, the original 1.0s of big data, let's call it the MPPs and the Hadoops, which were very much, coming about from this, as we see from the social media, companies, the Facebooks, the Yahoos. But we have different requirements on the street. So, we have an enormous requirement around enterprise. We're not optimizing, our cost structures to our margins. We're in IT, we're a cost center. So we have a lot of need to, disaggregate, compute from storage in our big data designs. We have resiliency needs in terms of business continuity, and we have persistence needs on the streaming side. So we can't have just, streaming in memory and deal with a loss and recover minutes worth by asking people to replay data for us. So we take a look at this design on this screen here, and we talk about how, we take the area of time of hours to the days to years of a data footprint, and how now Wall Street is becoming much more, of using big data in all of its real-time processing. And in that case, we're driving tremendous rates of innovation around the stream processing, the in-memory, to the operational data store, down to the data lakes and the deeper archives. And that, in turn, is providing us an environment to source data in a very large capacity back out to the deep analytics needed for surveillance and trading and compliance. But what we're seeing today is a tremendous need as it's being driven by regulatory, corporate risk, and surveillance, this holistic view on our data. As many of us have grown up in Wall Street, we grew up around, fixed income, equities, and derivatives, and all of them having their own silos of data. And it was very difficult for a firm to provide, a know your client at a holistic level, or just firm-wide risk, at any capacity, because our data existed in different islands. Because we had some structured data, semi-structured, and even unstructured, depending on which product and division we were coming from in the bank. And that's no longer acceptable. And so the technologies that we're talking about today provide us, not only, to address some of the introductory comments, lower cost of entry and better scale, but it's providing a uniform fabric for us to now, have multi-asset classes, being able to be stored in one location to provide that level of holistic surveillance, risk, trading analytics, know your client, at a rate that we couldn't have done in the past. So today what this diagram shows is really the path that we see forming in the sense of an overall puzzle, this ecosystem, of how this informatics is really a pipeline going from on the wire all the way down into the deep analytics. So if we briefly look into the left portion of the screen, we can see some of the technologies that are being used to deal with this ingestion off of many order management systems, EMS systems, market data systems, right? These are coming in on, through various gateways that most of us are familiar with on the street, such as, 29 West and TIBCO or JMSs or IBM MQ as an example. So what we're starting to see is the formation of some standards around Kafka as becoming the streaming messaging bus, and that becoming a very pervasive deployment model for firms to deliver streaming. But some additional technologies that are being leveraged to do the processing, and that really being the Storm and the Spark and the Apache Ignites. And obviously, most of us are familiar with the rework that's going on in Project Huron, right? And then there is very much the in-memory analysis of data. I wouldn't call them necessarily analytics, but this is an area that people are doing on-the-wire analysis. They're aggregating data. They're providing monitoring on that sector-level, aggregation, perhaps on, very simplistic forms of data aggregation, right? But we can't afford to lose that data, and that's where I think you're going to hear some of the innovation that's going on in a company, Aerospike, on how they're able to solve, not only, a solution for how to persist your in-memory and use their system as a landing zone for that in-memory to persist right off of, let's say, Storm as an example, right, or Kafka directly. But they're also now moving into and they exist in the space of the operational data stores, so the Cassandras, the HBases, Mongos, where people are, persisting their data for a longer term for search and analysis and time series. So you're going to hear from the guys in Aerospike and how they can kind of fit uniquely into those two parts of, I would say, the pipeline, where they have the real-time, persistence mechanisms on the wire fast data analysis, but also the operational data store where you need to store this for a longer period of time. And of course, then it's really, as we create these landing nodes on the operational data store, we don't plan to hold the data there for, years, but we do plan to hold them maybe for hours or if not, parts of days. But we need to be able to extract that into really this data lake, the deeper archive, very low cost, where we want to preserve our data and be able to, have schema evolution, but at the same time be able to ETL our content out of something like an HDFS, served by MapReduce in the Hadoop world. And that's creating a tremendous amount of opportunity for folks to persist logs, just various, unstructured data coming off of news feeds or market data in the structured side or trading and events. But again, being able to house these all in one location to serve as a central repository for all sorts of data, right? Machine-generated as well as human-generated. And then, of course, it presents it as a unified fabric for, the longer-term, more complex surveillance and trading analytics and compliance and regulatory. This is where the graph is starting to come into a very emerging market for the street, on how you can basically use graph technology to create all kinds of, unique relationships and patterns to help you discover hidden relationships. And again, the uniqueness here being not only that you can have these graphs and unstructured data, but you can tie them to the structured data and really unify, the data that you've once had in all these different islands of technology that could never be, searched in one single place. And so these new applications forming these integrated systems as a pipeline are driving a tremendous amount of technology innovation. And, we urge, organizations to look to the emerging technology side of infrastructure, not just the software, to really uniquely provide the capabilities that are going to be required for this next generation, system infrastructure. And you're, taking a look at, SAN-based or fiber-based, attached storage and legacy Oracle and Sybase are now becoming the mainframes of today. And so new types of technology on the hardware, new types of technology on the infrastructure software, such as, HPC file systems, are coming about to provide new scale and new models to, support the elasticity of these new types of databases. And I'll end on, the note of really the new age virtualization and what we're starting to see, the containers and the Dockers becoming a new foundation for serving the elasticity for hyper-converged next generation data stores. Because we don't want to have our own silo for streaming. We don't want to have our own silo for Hadoop and, let's say, our NoSQL databases. We are looking to see how containers can now create a unified fabric where these types of databases can share the same physical hardware, but yet create the right level of isolation of resource and capacity to support the elasticity that we would need to see during the trading operations. So the containers are starting with Docker become a really interesting foundation to create a converged multi-tenant cluster to support the big data and analytic pipeline. In addition, things like Mesos are providing an integrated framework for people to create better management of the elasticity and orchestration of that, and really creating a new level of private cloud and platforms as a service to support the next generation of really big data and the elasticity around that. And I'll conclude there. I know we've got a lot of presentation ahead of us. Clearly, I want to provide enough time for Brian from Aerospike to present his solution around NoSQL. So Brian, perhaps I should hand it over to you, and I assume we'll be taking questions towards the end of the presentation.
Hey, thanks, Steve. That was a great overview of what's happening in this new next generation of financial services. I'm going to spend just a couple minutes talking about Aerospike's solution, but for those of you who have not been exposed to Aerospike yet, but then really jump into all the things that Steve is talking about. Aerospike is now deployed with and contractually working with a number of financial services companies, and it's very exciting for us at Aerospike to be able to be a part of this new next generation. So Aerospike is a company that is a venture-funded Silicon Valley company. We've been around for about 6 years. We're full of both database experts, but also scalability and high-performance folks who grew up with the internet. Various people were from the cell phone industry, embedded industries, but also internet companies like Yahoo, as well as some folks from IBM, DB2 Group, as well as Sybase. So it's an interesting group of engineers who have come together to build a new distributed system around databases. We've really seen that there's a need for an operational data store, that database on the front edge of your application that could power internet-style loads at very high rates. And we found now that that kind of solution is of great interest in financial services, telecom, retail, many other systems. So where we started with was as a essentially key value store, but then adding a number of indexing features and also greater integration with languages. At Aerospike, we found that there's a new application development paradigm that started mostly within ad tech, but is now spread to the rest of the internet companies and is now spreading to the enterprise. We can call this the NoSQL solution, but what it really is moving from a deployment pattern that had a load balancer, a cache, a relational database, and then a SAN underneath it for storage, to a simpler system that is on this slide. So this new architecture is one that incorporates big data, because big data informs everything that you do, the personalization, product mix, etc., but then feeds that into the front-edge application. So you want a processing layer, that's what's the app server in this system, and using next-generation app servers such as Node, such as Nginx, and other even Java-based solutions, and then mating that with a high-performance database. So instead of simply having a 4-layer system with a cache and a storage layer, simplifying it to a compute layer and a storage layer that's the database. This provides an extra layer of scalability because you don't really know which level you're going to need, if you're going to need more compute or you're going to need more storage. This kind of system where it's a cluster of stateless app servers and then a clustered storage layer is one that has become prevalent within the internet community. At Aerospike, we've had the pleasure of working with a large number of internet companies, especially ones in Manhattan that have worked within ad tech. I've talked in other briefings and other webinars about the incestuous nature of ad tech and financial services, and how ad tech is also a trading system with real-time bidding today. It's a very interesting market, but not what we're interested in talking about today. Compared to some of the other NoSQLs, Aerospike is known for its high performance. So compared to, say, Cassandra, we have a number of benchmarks out there showing much lower CPU use and thus much better server use than Cassandra. So in a lot of cases, if you have a Cassandra deployment you're considering, Aerospike might be the right solution for you. And you can go online and search for some of these further information, benchmarks, how to run them yourself for your workload. So overall, Aerospike is a distributed system that's going to handle the data load primarily from a key value perspective. And I'm going to go into what that really means in terms of financial services use cases that we've been deploying with. But our goal is high availability, and high availability means having multiple servers. It means having a cluster. It means having a smart client that can route any individual request to the right server that has the data, and also to rebalance the cluster in real time. So we're known for very high availability as well as very high correctness. And our technology is all available on the website. We are an open source company, so you can dive in deeper both architecturally and in terms of our deployments by going to our website or other online sources like Stack Overflow. So let's get into how this actually applies from the internet use cases to both financial services in terms of fraud, as well as the kind of order management and trade management systems that Steve was talking about. So what we find with fraud detection is that there is a new desire to use as much data as possible when doing payment processing and transaction processing. So with payment processing in particular, there's a lot of regulatory needs in terms of what data you can use, but there is a desire to fold more and more types of data to the different kind of fraud prevention systems you have. The systems that have been used in the past have been traditionally rules-based systems using relational databases. So you have typically a system where there's a back end that is creating new rules, and then every month, or even sometimes once a year, push those rules to a front-edge system that is actually accumulating the data. And these systems would typically be done with a SQL-based solution. However, the threats that occur, both with internet processing but also brick-and-mortar payment processing, much faster evolving. You may have a threat that develops and patterns of threat that you can see just in a matter of a few days. And you need to get that new algorithm online to be able to track down that fraud. And also, an underappreciated aspect of fraud detection is reducing false positives. Every time that a transaction is denied, either online or in person, is a missed sale. And folks within payment processing are very sensitive to, first of all, the amount of fraud that occurs. 4% is the typically quoted online fraud number, as well as the problem of false positives. You really don't want to deny a credit card, especially online, where it's so easy to switch over to some other online site and make your purchase there. So those are the problems that folks are trying to solve in fraud prevention. The model that they're using, if you remember back to what I was saying about the advertising and internet companies, looks surprisingly similar. So on the left-hand side, we have your business transactions, which is to say a payment request. Hey, I've got a Visa card, and this guy wants to buy this particular basket of merchandise. In North America, those rates are running for a large payment processor in the range of 500 to 1,000 to 2,000 requests per second. So think of those as a business processing engine. That decision engine is your CPU. That's actually got the algorithms running and the math running that will make a fraud determination system. The goal with these next generation systems is to have as many calculations as possible with as many different data sources in order to create the highest possible result out of the system. So this is where you get into the need of having a database that is capable of several million transactions per second. The models that we're seeing in the field from an Aerospike's perspective are models that rely on 20 or 30 pieces of data for a fraud score for a given transaction processing, but in fact trying to reach up to 4,000, 5,000 transaction pieces of data in order to make a valid fraud score. Let's go into depth. I'm going to go a little bit quickly here, but let me try to sort of cement what happens here. So in fraud processing now, simply having a filter and a score, people are trying to use things like machine learning, and that's a very interesting area of applying big data. In machine learning, what you have is what's called a feature. Now, this doesn't mean a software feature, a database feature. It means a feature of your data, and anything can. When we work with our customers, of course, they share with us under NDA some of the features that they're using, and I can't talk about what an individual customer uses. And I'll go into a particular sort of example case. But remember to translate this into any possible feature. The important part about using fraud detection is there's a lot of great libraries out there, and those libraries are not supported by relational databases. What you have is you have Java-based systems usually, but also other languages such as Python, and you have libraries that have implemented machine learning strategies. You need to mate those to high-performance data. So let's go into a quick example, and I'll show you the kind of discussion we tend to have with customers about this. And that's the case of IP addresses. Let's say as a payment processor, you can keep track of the different IP addresses that you get transactions from. And you want to keep track of either traffic or buying patterns, actions coming from those in an online scenario. So in this case, your feature is your IP address, and you want to keep recent data. You know how many IP addresses there are in the world in IPv6, and that's between 2 billion and 4 billion. So in a NoSQL paradigm, think about that as your object count. Now you've got a few ranges of network addresses, but a range of a network address in IP has only limited validity. The size of that and scope of that will be determined by your back-end big data system, your Hadoop processing system. The kind of discussion that we tend to have to someone implementing this is one where they're currently using a relational system, one of these rules engines, and they're thinking about how to change over to a NoSQL. So what happens is, someone says, hey, look, out of my big data system, I've got something like a start IP address and an end IP address. And I have some idea from my back-end system, my analytics system, what the chance of fraud from this range is. So I'm going to put that in a database. And I'm going to put a table, and the table is going to look kind of like this. And then I'm going to do a select. I've got an IP address, and I want to sum up the fraud scores for this particular IP address by looking at the ranges. And that's a pretty typical way of thinking about this kind of system in a relational paradigm. The important thing to notice is this select is a range query, which in database theoretical terms means it's fairly slow. You've got to look at an index that's a range index. That kind of lookup is going to be one that is hard to distribute. Distributed range indexes are very difficult from a computer science perspective compared to a key value lookup. When you're trying to get to the range of building a system that is capable of millions of transactions per second, as we showed is necessary, you need a system that is not based on this kind of lookup. But the real problem comes next, which is, okay, great, we have a fraud score. What if we want to do more work on the front edge of my processing system? What I really need is a set of behaviors, and have those set of behaviors available at the front edge for machine learning algorithms or whatever next generation algorithm you want. You want all of that not just to be back end, but that data is pushing to the front end. So in SQL, how would you do this? Well, you do it in a table as it looks up, and you would do the kind of queries that you see on the slide, where you're going to say, okay, so give me for a particular range of IP addresses all of the behavior that has been that is available. Again, this is a range lookup that's going to touch a lot of rows and be pretty slow. Now, there are ways to optimize this, and you have a whole set of DBAs on staff to work on optimizing these indexes. How does this kind of system work in NoSQL? Well, in NoSQL, what you're going to do is you're going to embed more of the processing and data logic in the data structure and make it available through key value style lookups. In the case of IP addresses, it's pretty straightforward. What you want is, for example, a key, one table that says, hey, I've got a particular class C IP address, and that's going to create a list of networks. Remember that in the NoSQL system, you're building up things like lists, and that's a very common NoSQL paradigm. And then you can take that list. Now I've got a list of keys. I can translate that into a set of key value lookups. So instead of doing a range query, I'm doing two requests, but they're both key value. That switch in your range queries over to multiple key value lookups is really one of the keys to using these next generations that at Aerospike we have to work with customers to get them to understand. And in fraud processing in particular, getting through that concept of moving to a key value lookup is really one of the most important ideas of moving to a NoSQL style solution. When you're also then trying to build in behavior, again, think about those lists that you can build in a NoSQL store. So you have a particular IP address, and then the key that you see on this slide is on the right-hand side where you have a collection of behaviors. So think about, I've got an IP address, and I've got a list of its recent behaviors. I know exactly where that data is, instead of having to go throughout the database and pull individual entries from some super large table. That is really the key to thinking about this kind of processing system for fraud in a NoSQL lens. To have a successful implementation and a high-speed system that is really capable of scaling to a much higher level, supporting new data types. Now, the key to this system is also that you can use different kinds of libraries capable of doing machine learning, systems like Spark, which may have a SQL interface, but are also really in the NoSQL family. So mating your NoSQL system to an operational system is key. And again, this goes back to that modern scale-out architecture that has a stateless app server as well as a high-performance operational store. Now, the problem of building a order management system that uses these is really very different from fraud. So I'm going to transition over to talking about that kind of case now. So what we're seeing, and the kinds of cases that Steve was talking about earlier, is a case where processing system, you have a variety of states that are already well known in the industry. Now, unlike fraud processing, where people are coming from SQL and relational, the guys within order management and order processing in financial services really already use NoSQL. And they use RAM-based systems like KX, KDB that are already really focused on using semi-structured or unstructured data. We have to get people like this into thinking NoSQL. They already are fundamentally using NoSQL solutions today. And yet they need a system of much higher scale. It is the problem that Steve was talking about bringing in new data sources, bringing in new applications, but also the trend of using multi-asset data. Today's solution, siloed individual trading and systems. Instead, what you have is you have individual data silos that have their own databases, their own inflows, and their own data structures and sources. And that's okay. I mean, it's been working for us for decades, having each one of these different desks or business units choosing their own technologies and having their own data store. But with the advent of this new world of next-generation financial services, we're seeing a desire to really use that data across the different that can be used, first of all, for being able to do a broader risk calculation, a broader portfolio understanding, and also to give customers who are online looking for trade status a better and more accurate view. Most people who are used to the internet, they don't want to see what their trade is tomorrow or how it settled tomorrow. They want to know the status of that trade right now. So it's in some sense exposing some of the technology that might be available to an in-house trader throughout the entire retail system as well. So the one deployment environment that we've seen so far is trying to building a system where your operational data store spans multiple order management systems. Now, this is a pretty revolutionary idea, to be honest, to try to use the same data store across multiple order management systems. But it is possible now with these NoSQL solutions such as Aerospike. With this kind of solution, you do have a real multi-asset aggregation. You get the actual state of the actual trades, how they're filling, what the parent-child relationships are within the order management system become exposed across business units and to potentially to analytics units that can look at the real status of today's trade. Now, in old technology designs, you needed to have those silos simply to protect the individual systems. I mean, these are high performance, latency guarantees, etc. And now, with the kind of distributed system that NoSQL provides and Aerospike provides, there's the idea that perhaps we could use a single data store across. We are seeing that trend now within Aerospike's customer base. Better system that's possible, which is the idea of building a hybrid system that takes the existing silos and the existing trade data and building a post-order analytics system. So you take every order management state change and you pass that on to a shared message bus, like Steve was talking about, where Kafka is becoming the prevalent standard, but really you can use any system. You could use TIBCO's system or one of the other older systems. And then passing that into a processing system that is perhaps Apache Storm-based, perhaps it's next generation with the Heron project, or perhaps it's Spark. Now let's separate those out for a minute. The kind of processing that Storm is capable of, where you have a bolt and you can use the state in the database to enhance the bolts, to add more trade data, to essentially find user data, and to enhance the message and decorate it with more information. that really should be very familiar to someone in financial services because it's really a CEP-style system without a lot of the overhead and baggage that is accumulated around CEP. So you've got an event, you need to decorate it, you need to act on it, and you need to have an event flow that is reliable in real time. And that's one deployment pattern that we've been seeing at Aerospike. So you're taking these order systems, flowing them out because you don't want to touch your existing order management systems, and then building out a separate data store. Now, Spark can be used for more analytics and in-flight analytics. So let's say you have a particular aggregations, particular queries that you know are going to be common for keeping aggregation contexts and keeping partial results, so when you need going past. Now, both Storm and Spark are of the next generation internet-style systems in that both of them are clustered. And thus, both of them have in-memory different state. And part of the problems with them, naturally, is a reliable data store. If you've used Storm or Spark, you know that they keep a lot of data in RAM on an individual. And if that cluster node fails, you're going to have partial data returned, and that's not okay for these systems. So we are using Aerospike as the reliable store underneath both Storm and Spark. Aerospike has available both Storm and Spark connectors for this use case. So let's talk for 1 second about the impact of Flash in this kind of system. So there's a lot of skepticism within financial services about the use of Flash within these kinds of systems and the reliance of RAM. Aerospike has found that there's some cases that work great for RAM, and you need a clustered high availability database like Aerospike for RAM, but we've also found that Flash provides some new opportunities. So in cases, for example, with fraud detection, where you really want to keep hundreds of terabytes of data and have that online operationally, we're finding that that is now possible with Flash. Aerospike has worked a lot with different manufacturers of Flash devices in order to make sure that the database and the system calls that we're using, but also that the devices themselves are capable of this kind of operational workload. There's been a lot of work within Flash to support streaming and support systems like Hadoop, but really Flash is great for getting a particular piece of data. One benchmark that we did with Intel's help uses one of their new drives, which is an NVMe drive called the Intel P3700. There's also a Samsung drive that is similar NVMe drive, and a shift now from what's called a card-based solution, where you're putting an NVMe drive in chassis, like the picture here, as well as what's called the new U.2 form factor, where NVMe can be put in front panel and thus hot swap attach. So there's a lot of work that's happened within Flash that now makes it possible to use Flash to create 100 terabyte databases. And that can be pretty exciting. So one of the changes that occurs in these next generation financial systems is the ability, from a mathematical perspective and a practical perspective, to go beyond the few terabytes that you might have previously used. Start thinking about 100 terabyte market data systems that are actually closer to the front end and operational. And we're having a lot of those discussions at Aerospike because we've been used within internet companies to build out systems of this scale for advertising and advertising technology companies, where you're taking behavior and being able to accumulate on a user-by-user basis for the entire internet. So based on the experience that we've had, Flash can be used in a reliable way, but you need a database that's written for Flash and doesn't just treat it as a file system, which is what we've done at Aerospike. So based on the years of experience that we've had building Flash systems, building operational systems with extraordinary availability, we're really looking forward to this next change in financial services and bringing some of the technology from Silicon Valley and the internet into some of these new processing systems. So that's the end of my prepared remarks. So do we have some questions from the audience?
Yes, so thank you very much to our speakers there. Do appreciate you giving the presentation. So let's move on to the Q&A session now. And I can see we do indeed have quite a few questions for our speakers. But if the audience has any more questions, please just type it into your box on your console, and I'll put it to the panel. We'll try to get through them all today, but if we run out of time, we will get back to you offline. So our first question is a simple one, really, and it's just asking what the panel thinks are the biggest causes of the data deluge at FI. So is it regulatory reporting or just simply a more complex FX market? So Steve, perhaps with your FS background, you might like to take that one.
Sure. I mean, as part of, Oktay's, Technology's business, I mean, we spend a tremendous amount of time, helping advise some of the largest banks in the world on what they should be doing with their new informatics space and, big data, right? And they really have us looking at all the different software changes that I talked about, combined with all the different hardware options to ensure that it's a very highly efficient and, optimized environment to deliver against, the business needs and around performance and resiliency. And many of the cases that we're seeing, not just with our clients, but through a lot of the dialogue and relationships we have on Wall Street, through Oktay, is very much the multi-asset class, kind of walk through that Brian just kind of, talked about. And, certainly that's combined with the pressures coming from the regulators. And, the regulators are not only interested in, kind of this holistic view on systemic risk and know your client, as well as, different, the way they're looking to surveil the environment. This is becoming more pressing to be real time. So historically, for the most part, Wall Street has been very overnight for the larger types of FINRA requirements and regulatory requirements here in the United States. But it's now becoming more needed to focus on the real time and the streaming. And that's why I think the combination of the technologies that we've talked about are so relevant in terms of how firms today are looking to solve, for the whole big data ecosystem. So it's truly a combination of the hybrid, kind of the multi-asset class aggregation, and as well as the regulatory.
Yeah, well, thank you. I mean, with the low yields, that's kind of encouraged the multi-asset class approach now. So that's a great point. And it seems to be, from what you're saying, it's a combination of market drivers and regulatory drivers causing this data deluge. So we've got things like BCBS 239, for instance, with their risk principles and all the reporting obligations that come with those. So just might be worth touching on, how a NoSQL database can help in this environment. So is there anything you'd like to add on that, or do you feel that was covered in the presentation?
I mean, I feel it was covered in the presentation, but, I think Brian really did a great job articulating the multi-asset class, and I thought, but certainly if he wants to add some more, I think that would make sense.
Sure. Well, I mean, I was going to turn to Brian next just because we have another question. You're welcome to jump in there, Brian, but we have a kind of more vanilla question in somebody asking if Aerospike works with Hadoop and or Spark. So maybe you can take that one and address the other one if you wish.
Yeah, sure. So as I was showing in the presentation, really these operational data stores and big data operational data stores have to exist in a big data environment that works with the technologies that we're talking about. So Aerospike always is in deployment with a big data system that always is a Hadoop system. So if you go back to that earlier slide that showed Hadoop on the right, and then that's really a placeholder for all of your analytics systems. We see Redshift back there. We see I think of it back there. I don't mean to denigrate the analytics systems. They're key in some very interesting technology. They might be MapReduce based. They might be relational based. Usually we see a blend. One of our early internet customers had at one count 15 different databases. And I don't mean databases, I mean technologies, right? They would have, they had Netezza in there, they have Vertica in there, all kinds of stuff. And then the question is always, how do you take those insights out of a Hadoop-style system, and analytic systems, and move them online? So absolutely, Aerospike has a Hadoop connector for that. We've got some example code on our website that makes it really easy to take your results and push them back into Aerospike when you've actually calculated them.
Right. Okay. All right. Well, Brian, and maybe the next question is for you as well. It's just really about the role of data tagging, time stamping, data cleansing, collections, sharing, all of these kind of things, and if that's relevant for a NoSQL environment. How do you feel about that? And perhaps I think the question is really talking about the bridge between structured data, which FIs have always had lots of, and unstructured big data.
Yeah, it's an interesting question. So when you look at order management, I'm new to the field, but I've been working with Steve and getting smarter on this. But as structured as it is within order processing, there's also a lot of unstructured relationships. So when you take something like a parent-child relationship in order to do slice and dice, and you have different fills coming in from different sources in different orders, that's actually not represented or implemented usually with a relational database. That's often implemented with a non-SQL solution such as KDB or KX. And so these guys are already used to message passing in CEP that is not SQL-based. So you'll take an order, that order will have a list of different fills and basically a list of parent IDs and a list of child IDs. And then it will often have what you might call a foreign key relationship. And really that's just a fancy word for saying, I've got an order ID. You want to go find out more about the order, take it and go look it up. I've got a customer ID. You want that information, go look it up. So I actually think the financial services guys are using the semi-structured system that they have and are already pretty sophisticated, very sophisticated in using non-SQL paradigms. I've been very pleased to work with them because I think that the systems they have are very sophisticated in terms of being able to deal with this kind of semi-structured data.
Yeah, yeah. And of course, it's an interesting debate because big data is just ever growing and driven by regulatory demands and also just market demands. So it's kind of quite a good question, I think. I'm not sure if, Steve, you want to add anything to it with your FS background, because big data traditionally is unstructured and obviously something that FIs would have struggled with, but perhaps not so much these days.
Well, I mean, big data, as we all know, is about the size of the data, right? The biggest thing I think for Wall Street and its real value is the variety. Like I said in the earlier parts of my discussion, we really had to create a lot of disparate, data repositories. You had your derivative instruments that were, highly structured, and you could never store them in the relational database. You'd have them in big blobs, right? So you could never, you'd have the same client, dealing with a derivative as you did an equity or fixed income instrument, but you didn't have them in the same place. So now I think the real value that I'm starting to see becoming more pervasive is really the fact on the variety side for the first time is giving the quants, internally a much broader capability to, look across all asset classes and truly start generating new outputs, based on their analysis of the data that they could never analyze before. And then you combine that, again, with some other content that was extremely difficult, anything off the semantic web. So if you even just think about news, being able to, ingest news in real time, natural language process it, and correlate that to highly structured data such as, the market data and the trading, you're again able to discover all kinds of new event-based trading or supply chain relationships through graph processing. So those areas are very new and emerging for the street in terms of not so much just the regulatory and surveillance, but truly, the next generation of strat development and algorithmic development, being able to take all these different kinds of data, store them in one place, yet analyze them, together. That's new.
Yeah.
And that's exciting. And that's creating differentiation again for these firms. And it becomes a race around the informatics, like we saw with the race for building trading systems. So informatics as a system is a very, very strong differentiator now for firms.
Yeah, I think that's a great point because we've seen that convergence between big data and the big computing to handle it, really, so you can actually turn it to your advantage and, gain business benefits out of it. Okay, well, that's great.
And
Thank
Neil,
you for
one
that.
thing I want to add here is that this is
Sure.
where Flash can come in the operational data store, in that moving to a bigger data set, as Steve is saying, that is so exciting with informatics. What we've experienced at Aerospike is that Flash can provide the price point where essentially you're taking your operational data stores that were big RAM hash tables or big single machine, and saying, well, wait a minute, if I'm living in a big data world, my operational data store isn't just a terabyte of RAM or even 8 terabytes or 16 terabytes. I want to get to hundreds of terabytes, and that'll allow me a serious edge. And if I can get that operationally, and then how do I do that? And the answer to be cost effective is usually Flash. And financial services, working with, say, companies like Fusion.io, have been on the cutting edge of that. We're now seeing a broader market that is operational Flash stores with products from Intel and Samsung and even existing folks like Fusion.io. So Flash really provides Flash the ability to operationalize these kind of data stores and is part of the drivers to this revolution.
Okay, wonderful. I'm conscious we're actually running out of time, unfortunately, but we do have another question, a bit more high level perhaps, but it follows on asking the panel to compare the FS sector and its big data handling capabilities versus other sectors. I mean, how does the sector compare versus others?
I mean, if I were to just take a stab at that, I mean, I don't live in a lot of these other sectors, but clearly, with Oktay Technology, we're starting to engage with organizations, and advising them on, big data and the types of technology and hardware and software they should be building. So it is taking us outside of our history of really a focus of Wall Street. So, I mean, what I will say, though, is fundamentally the streaming component, I think, is the real-time processing and ingesting of in-memory streaming and all the stuff we've talked about kind of on the wire. I think we're pushing the envelope a bit more in Wall Street than perhaps others, combined with the need for enterprise-grade resiliency. And, this is a key piece of, business continuity, where it isn't just about, having the data, and compute all combined on one machine, for processing, but really looking to disaggregate that where the compute scales independent of the data storage. In many cases, there are new types of data arrays, that are Ethernet-based attached with solid-state flash, NVMe, but all kinds of innovation that are allowing that separation to occur and give greater performance than what was even being seen running in the box. And that is really a big push to enterprise enable these kind of internet databases in a way that perhaps the internet companies or the social media companies didn't have to deal with. Again, I don't live in them intimately, but certainly looking outside in, this is kind of the big, why we were calling it the 2.0 of big data for the enterprise. It's really about the real-time streaming and the resiliency and business continuity that are seemingly very different.
Yeah. Okay. Well, that's wonderful. I'm conscious, unfortunately, that we're running out of time now. So I'd just like to kind of give the panel an opportunity, really, for concluding thoughts. Are there any final thoughts you'd like to add or points that you want to stress, perhaps?
The only thing I'm going to add, you really, to evolve your firms to be competitive, looking to the traditional databases and fiber-attached, storage, these are really, as I said earlier, becoming the mainframes of today. You really need to get yourself skilled. You really need to be aggressive in helping your business differentiate with this whole new, complex, informatics. And it's real. It's not a trend. It's here to stay, and it's really evolving. Pretty much every part of the IT stack, from skills to technology, including monitoring and tool sets for the developers. It's a whole new world that's happening. It's real, and get yourself embedded in it.
Okay. Well, that's wonderful. Thank you, and thank you to Brian.
So at Aerospike, just to wrap up, what we've been seeing is everything that Steve said about this being real. cutting-edge internet companies, advertising companies, social media companies have really been at the forefront of building out recommendation systems, how to price cabs in Uber, how to price advertising. There's really been some exciting real-world applications of pricing technologies and by some of the market leaders in the internet. And Aerospike has been there powering a lot of the internet companies and internet advertising. So we're here and improving NoSQL to deal with the demands of regulatory and data volumes, and very excited to work with financial services firms, and happy to field any interest from companies that are working in this area to add to our portfolio.
Wonderful. Okay, well, thank you, Brian. Thank you, Steve. I think we've had a good discussion there today, but we are out of time now, unfortunately. So just like to remind our listeners that the recording will be available on Bob's Guide. So please look for it there, and thank you for attending today. We look forward to welcoming you to another Bob's Guide webinar in the near future. Goodbye.